Hello everyone, today we are starting 4.5. So in this exercise we have to solve polynomial equation. How to find the solutions of that? That is a solving polynomial equation. Here equation is given solve 2x cubed minus 12x squared plus 18x equals to 0. When we start the factorization in the last video, we take common terms. The terms which can be taken common, just take it outside and then find another factor. So we will do the same thing here. 2 is a common factor with the all three terms. So I take 2 common. And x cube, x square and x. So maximum power of x that can be taken out, that is x, because this is x power 1, this is 2 and 3, and I can take only x common because that is available in all three terms. So I take x out and it's left with x square minus 2 6 are 18 and 2 9s are 18 equals to 0. 2x as it is. What is this? This is a factor of x minus 3 whole square equals to 0. Now, if the two term is a product of two terms 0, it's known as a zero product property. Zero product property says if the product of two terms are 0, either the first term 0 or the second term 0. So here, either the first term equals to 0 or the second term equals to 0. 2 times something is 0. 2 is a constant. 2 is a different constant. It's not a 0. So you only left with x equals to 0. Or here x minus 3 square equals to 0. If square of something is 0, that means the term itself is 0. And you will get x value is 3 from this. And here is x 0. So you have two roots, 0 and 3. No doubt 3 is a repeated root. 3 comes 2 times. But 2 are the different. There are two different roots, 0 and 3. Okay. Next question we have, find the zeros, then sketch the graph of the function. Let's find the roots first. What I can do, I can clearly see I can take negative 2 outside. So I take negative 2 outside. X power 4, 2 8s are 16, x square. 2 16s are 32. Okay. Can you factorize it more? So this is x square minus 4 whole square. And as I want a solution, so I have to keep this term equals to 0. So you will get x square minus 4 square equals to 0. X square minus 2, not x square, x minus 2. X minus 2 and x plus 2 equals to 0. Because the square of something 0, that means the term itself is 0. From here, x square minus 4 is 0. And I apply the formula a square minus b square, which is a minus b and a plus b. So here you have a root x equals to 2 and negative 2. Whenever a word or whenever a root is repeated, every repeated root has this kind of curve for that point. Suppose this is point 2. Either your curve will be like this for the 2 or the curve will be like this for you. It's a U shape for that particular root. It's an even root. Whenever a root answer, if a root is repeated even times, you will get this curve. Let's start it. Minus 2 and 2. We learn the AND behavior also. Check it. Limit or directly says where the function is go. Function will go, it's infinity power 4, infinity minus times, so negative infinity. Fx goes to negative infinity if you are going toward positive infinity. Okay. Now, if you choose a negative infinity, if you are going toward negative, negative power even is positive, outside is still negative. So your answer is negative again. So x approaches to negative infinity, function still goes to negative infinity. This is the property of an even degree polynomial. Whenever the degree of the polynomial is even, the behavior on the both end will be same. The coefficients are negative, so it is moving toward negative side, negative infinity side. So let's see. That means after 2 it's go down. After negative 2 it's also move up to down. You can check at 0. At 0 the value is negative 32. Maybe negative 32 somewhere here. So it has to move down. It will touch this point and go up like this. You can see this graph is formed by taking 2 and negative 2 like this, a U-shaped curve, down U shape. Always, whenever the whenever the root is repeated even times, you have this type of shape for that particular root. Maybe then some other root 3 and that's not repeated, then it is not like that. It will cross it, directly cross it and comes down. It's like that. If it is repeated, but then it has to move like that. Okay. Next, rational root theorem. In the rational root theorem is, if we have a rational polynomial, an x power n, an minus 1 x power n minus 1, and so on, a1x plus x naught, an minus 1, ai's, or you can say all ai's. It's not a naught, x naught, it's a naught. All ai's are integer. Then possible rational roots, if we are already defining a here, so remove this. If we have a polynomial an x power n plus an minus 1 x power n minus 1 plus so on a1x plus a0, and all ai's are integer, then possible rational roots are p over q. What is p? P is the factors of a0 over factors of an. So this will tell you what are the possible roots, possible rational root of the given polynomial. Okay, let's solve for this question. It says find all the solution for this. First, I will try to use the same thing, rational root theorem, p over q. It's 20 over 1. Factors of 20 are plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, and plus minus 12 over. What are the factors of 1? Plus minus 1. The total factors will remain same. This. Okay. Now, if this polynomial has a rational root, it is it is only belong to this numbers. Only belong to this number. You can check it one by one. If I choose for 1, so I am using the synthetic division. I choose for 1. It is a 1. Coefficient is negative 8, 11, and 20. 1 comes down. 1 into 1, 1. Negative 7. Comes down. Negative 7. It's 4. 4. You are getting 24. It's not a 0. Remainder is not 0. That means 1 is not a root. Now change to negative 1. 1, 1. Negative. Negative 9. positive 9. 20 minus 20, 0. As you get 0, so that means x plus 1, or you can say x equals to negative 1 is one of the solution. What are the remaining solution? Use this quotient polynomial. Constant term, term with x, term with x square. So x square minus 9x plus 20 equals to 0. 5 4s are 20 and 5 and 4 9. So x square minus 5x minus 4x plus 20. I take the factors, I take x common, minus 5. Then I take negative 4 common, x minus 5. X minus 5 is one of the factor, x minus 4 is the another factor. So if you solve it, you will get either x is 5 or x is 4. You got the two values from this, one value from this. So total roots are negative 1, 4 and 5 are the values of x. Done. Next is find all real roots for this. Here I will just solve here for the what are possible roots. Remaining you can try yourself. Possible rational roots. It's 12 over 10. What are the factors of 12? Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6 and 12 over. What are the factors of 10? Plus minus 1, 2, 5 and 10. Now start dividing. If you divide each term with 1 or negative 1, it's still same. So it remains same if you divide with 1 or negative 1. Then you divide with 2. If you divide with 2, 1 by 2. So plus minus 1 by 2. 2 by 2 is 1, already used. No need to write. 3 by 2. 4 by 2 is 2, already used. 6 by 2 is 3, already used. 12 by 2 is 6, already used here. Already written these values. Now divide every term with the plus minus 5. 1 over plus minus 5, 1 over plus minus 5, 2 over plus minus 5, 3 over plus minus 5, 4 over plus minus 5, 6 over plus minus 5, 12 over plus minus 5. Okay. Next, if you have to divide with 10, so plus minus 1 by 10, plus minus 2 by 10. 2 by 10 is 1 over 5 and 1 over 5 is already written here. Then 3 over 10, 4 over 10. 4 over 10 is what? 2 over 5. 2 over 5 already written. No need to repeat anything. 6 over 10. 6 over 10 is 3 over 5 plus minus 3 over 5. That is also written. And the last is 12 over 10. 12 over 10 is 6 over 5. That is also used. So that's it. There are no other possible roots. These are possible rational roots. Okay. From this you have to check what are the possibilities. Next, irrational conjugate theorem. In this theorem, if your polynomial is if your function is a rational polynomial, if function is a rational polynomial, what do you mean by rational polynomial? Rational polynomials mean when the coefficients are rational. If function is a rational polynomial, then a plus root b is a solution. Then also a minus root b is a solution. So basically, if a constant plus irrational number root b is a solution, then a minus root b is also a solution. So that is known as a irrational conjugate. This is irrational conjugate. Conjugate means there is only difference of a negative sign. Irrational number with positive sign, irrational number with negative sign. Maybe negative sign is given and then you will say a plus root b is also a solution. Okay. See this. It says write a polynomial function f of a least degree that has a rational coefficient and the leading coefficient 1 and the zeros are 3 and 2 plus root 5. What are the zeros? 3 and 2 plus root 5. We just write here if in a rational polynomial a plus root b is its answer, then the minus of that, so that means 2 minus root 5 is also a solution, even though they didn't write it. You have to write from your side by this theorem, irrational conjugate theorem. So it has total 3 roots. 3 roots mean the least degree will be 3. Least degree is 3. Because we are not considering any repeated root. Repeating root is possible. We are writing the direct least polynomial with these roots. It's a degree 3. Then how you can write? For this, you will get the factor is x minus 3. For this one, factor is x minus 2 minus root 5. For the next, the factor will be this. Keep the first factor as it is. Now look at the next. In the next, try to take this as a single term. X minus 2 as a single term. X minus 2 as a single term. So what you observe here? It is look like a minus b, a plus b. So whenever you have a minus b, a plus b, what's that? A square minus b square. X minus 2 square minus 5. X minus 3 as it is. So this is a polynomial. Done. Okay. So we did up to this. This was the last topic in the 4.5. So in the 4.5 we talk about the solutions, graphing, and then rational root theorem, irrational conjugate theorem, and how to find a least degree polynomial using the irrational conjugate theorem. Okay, I hope you understand. If you have any doubt, you can ask in the comment section. Thanks for watching.